In this video, we are going to talk about sign charts. It's going to be the first of a few videos on sign charts, and sign charts are going to be really important to us as we go through this class. So I suppose a reasonable first question is, what is a sign chart? So to answer that question, I'm actually going to start with the following statement, and I'll give you a couple of examples to illustrate it. Any inequality is equivalent to 1 with 0 on one side. Even if you're not totally sure what I'm saying here, I think this is something you can all believe. So for example, I'm going to do a couple of examples here. Say that I have the inequality 3x minus 7 is greater than or equal to x plus 2. So this is a linear inequality, and I'm going to mark that, and you'll see why that's important later. It's a linear inequality, so if we wanted to, we could actually just move through the process of solving it. Go ahead and move everything to one side, get x by itself, and then we see the solution. But let's not do that right now. Let's move everything to one side. So let's move everything to the left. So we'll subtract x from both sides, and we'll subtract 2 from both sides. Okay, and so what we end up with is 2x minus 9 is greater than or equal to 0. So now I want to take just a second and I want to talk to you about this right here. Greater than or equal to 0. Another way to say that is positive or 0. So I'm going to leave that there for right now, and we'll look at another example. So say that we have the following inequality. X squared minus 5x is less than 2x minus 7. Okay? So this is actually a nonlinear inequality. And that's interesting because with linear inequalities, you can move things around so that x ends up by itself on one side. With nonlinear, you cannot do that. So we are already kind of thinking about the fact that we couldn't use the same techniques that we used in the previous example, for example, to solve this inequality, because no matter what you do, you're not going to be able to get x by itself on one side and no x's by itself on the other. So let's do the same thing we did in the previous example here. So we're going to subtract 2x from both sides, and we'll add 7 to both sides. So that gets us x squared minus 7x plus 7 is less than 0. And what I want you to notice in this case is that less than 0 means negative. And in fact, strictly negative. Since this is a strict inequality, it's not less than or equal. We can actually just say this is strictly negative. In other words, so what we're seeing here, we see that any inequality boils down to the question, when is some expression positive and when is it negative? So in subsequent lessons, we're actually going to dissect more carefully, how do you construct a sign chart, and how do you start from scratch. But for this lesson, I actually want to look at how we would introduce graphing and how we could use a graph to help us solve this. So here's an example, and we're actually going to solve this inequality. Except rather than using purely algebraic techniques, we'll say using a graph. Okay, and here's the inequality in question. Let's look at 2x cubed minus x plus 1 is greater than or equal to 3 minus x. Okay, actually, let's do 3 minus x squared. There. So what I'm going to do is I'm going to start with exactly the same thing that I did in the previous example, and I'm going to move everything over to one side. So I'm going to add x squared to both sides, and then I'm going to subtract 3 from both sides. And that gets me 2x cubed plus x squared minus x minus 2 is greater than or equal to 0. So what I want to point out to you, greater than or equal to 0 means positive or equal to 0. And I'm going to go ahead and use a graph here. So I've actually got Desmos open here. So we're going to pop Desmos here, and I'm going to turn on my Wi-Fi so that we can use it. And what I'm going to do is I'm actually going to put this expression into Desmos, and I'm going to have it graph it for us. So we have 2x cubed plus x squared minus x minus 2. Okay, so I'm going to go ahead and kind of close this out so that we can see the graph more clearly, and I'm going to zoom in a bit. So look what we have here. We have a portion of the graph where the graph is below the x-axis. So I'm going to kind of trace here. So if you're looking at these points as you're kind of tracing along, all of these points, the value is greater than 0. So remember, we talked a little bit about graphing. So the x values show up on the x-axis, and the value of the expression shows up on the y-axis. So like this point here, the y-coordinate is positive. That means the value of the expression is positive there. When x is 1, it's equal to 0. And all of these other ones, every one of these points, as I'm tracing along, all of these other points, the value of the expression is negative. So if my question is, where is this expression, positive or 0? Maybe you all can answer the question with me. It's positive or 0 if x is 1 or greater. So for any value of x greater than or equal to 1, the value of our expression is greater than or equal to 0. So we can go into our example here, and we can say that the solution set consists of all values of x that are greater than or equal to 1. And you'll see I wrote in an interval notation. Since we've got Desmos here, let's go ahead and pull up another example. So let's, again, we'll solve this inequality using the graph. Okay, so solve this inequality using a graph. And so let's look at x squared minus 5x plus 2 is strictly less than 2x plus 5. Okay, so same thing. I'm going to go ahead and move everything over here. So, I guess I can't choose colors. So I'm just going to use black. So I'm going to subtract 2x and I'm going to subtract 5 from both sides. Okay, so that gives me x squared minus 7x minus 3. And I want that to be less than 0. And again, I'm just going to point out here, less than 0. That's asking us where is this expression going to be negative. So now let's go back over to Desmos. Let's X out this previous example. And now let's look at x squared minus 7x minus 3. Okay, so there's the graph, and I'm going to zoom out a little bit so I can see the whole thing. Okay, and so I want to know when is the value of this expression negative. So again, remember on a graph, we see the x values on the x-axis and the y-coordinates. Those are the values of the expression. So we're looking, if we're looking to see where the expression is negative, we're looking to see where is the y-coordinate going to be negative. In other words, where is the graph below the x-axis? And that happens between these 2 points. Now, what you're surely noticing here is that these points are kind of weird looking decimals. And what that is pointing to is that, in fact, the points where x squared minus 7x minus 3 are equal to 0 are probably irrational. So this is where it might be good to actually use a little bit of algebra to maybe figure out with the quadratic formula what is the precise value where x squared minus 7x minus 3 is equal to 0. But we're not going to worry about that for now since this is just our first lesson. So we're going to go ahead and say that the solution here, the solution in this case is all the real numbers between negative 0.405 and 7.405. Now remember, this is an interval, and our inequality was strict, so being equal to 0 is not acceptable to satisfy this inequality, and to indicate that we're compliant with that, we're going to go ahead and use parentheses to show that the endpoints are not included. So this is a really good introduction to kind of what a sign chart is and why we would be using it. But I will finish this lesson by saying that a sign chart is an actual chart that we're going to learn to construct that shows us where a given expression is positive and where it's negative. So in subsequent lessons, we're going to talk about the process of constructing a sign chart, and then we will finish the lesson by looking at how do we actually use sign charts to solve nonlinear inequalities. All right, that's all I have for you this time. See you next time. Bye.